Hello there, we're going to be looking at the chain rule as part of differentiation in Edexcel. This appears in core 3 and another example may appear in different modules, but that's the one I'm focusing on for now. So we're looking at 3 functions that you can use the chain rule for. But first of all, we're going to look at why we know we can use the chain rule for these particular functions. So if I take the first one, the reason it's a chain rule is that it's a function within a function. By that I mean that if we take one function is that we've got e to the something, and the second function is our x squared plus 5. So the reason that we can use the chain rule with this particular scenario is that we've got a composite function. Similarly with the second one, y equals sine 2x, f of x is sine x and g of x is 2x. And once again, we've got a composite function. And finally for this one, to appreciate this as a composite function in the same way as the previous two, it's worth rewriting using a bit of indices. So as the denominator to the power -1, and then we can appreciate that we've got one function, which is that, and we've got our g of x, which is the part inside the brackets. So once again, a composite function. So to use the chain rule, it's got to be a composite function of this kind of form. So what we're going to have a look at now is how we can differentiate these 3 functions using the chain rule. And I'm going to introduce the chain rule to you now. So the chain rule is found by using, there's the chain rule. So in order to work out dy by dx, we need to work out dy by du and du by dx. So this extra variable u has come in, and that relates to the 2 functions that I talked about moments ago. So for this one here, u is like the g of x. So you let u equal the function within the function. And what that allows you to do is you've got y equals e to the u, and you've got u equals x squared plus 5. So if you differentiate this part of it, you get dy by du. And if you differentiate e to the something, it stays the same. If you do end up with an extra function in here, then it would be another chain rule. Du by dx is 2x, and therefore applying the chain rule, dy by dx is equal to dy by du times du by dx. So that gives us e to the x squared plus 5 times 2x. And that will be finally written as 2xe to the x squared plus 5. And that's our final derivative of our original function. For the second one here, we're going to do the same process. We're going to identify our u. We're going to do the substitution and find our dy by dx. So in this one, you might want to pause the video and decide what your u is going to be, have a go at it and see if you were right, and same for the final one too. So in this case, u is going to be 2x. So we've got y equals sine of u and u equals 2x. Differentiating this with respect to u, the derivative of sine is cos, and the derivative of 2x with respect to x is 2. So to find our dy by dx, we multiply those together, giving us 2 cos of whatever u was, which is that. Finally, there's this one. Now, before, you remember I rewrote it as 2 and then put the denominator to the -1. So in this case, see if you got it right, u will be x cubed minus x squared, and we've got y equals 2u to the -1. Just to be thorough, I'm going to move them around. Now you think that probably doesn't matter, but in terms of exam technique, it helps to have a little system that you stick with when you're writing these questions out, and just avoids any problems. So we've got dy by du, which would be minus 2u to the -2, and then we've got du by dx, which is 3x squared minus 2x. So what we're going to need to do is multiply those together, and we're going to end up with -2, and I'm going to put u back in, and that's the -2, and that's being multiplied by our du by dx. And then just to tidy all of that up, -2 times 3x squared minus 2x, and that will be all over x cubed minus x squared all squared. So there's the process for applying the chain rule. You find your function within a function, you make one of the functions u, the one inside the function, and then you need to find dy by du, du by dx, and you can multiply those two derivatives together to get dy by dx, therefore finding the derivative of the original function, which will then allow you to go on to find gradients and such if you need to.